most welcome to my channel. Today we shall be learning to implement Heapsort algorithm in Python. So Heapsort is basically a sorting technique based upon a heap data structure. If you haven't read about heap data structures, please do. And if you haven't read about binary tree data structures, please do, because that's what basically Heapsort uses. So it's basically a comparison based and also an in-place sorting technique, and by the way, it's not a stable algorithm. So to implement Heapsort, we make use of a min heap or a max heap. We create a min heap or max heap out of the given array or elements, and then the root node is either the minimum or the maximum respectively. That's how binary trees work. So to create a maximum heap, usually a root tree is the node at the root is usually bigger than the child nodes. So that's it, basically what it means. So Heapsort actually involves two steps, where you create a max heap or min heap, or then you delete the root node of the heap formed in every iteration. So that's what basically it is. A binary heap is basically a complete binary tree, and it means that every node can have at most 2 elements, hence binary, and those elements are filled in the nodes from left to right, and that's how the indexes are done actually for a binary heap. So I think let's get started to see what exactly I'm trying to do here. So to implement this, we need a heap5 function. A heap5 function is going to help us build a maximum heap, and then the maximum heap element, which will be at the root, and that means the first element at of the array will be the maximum in the maximum heap. So let's get started. So we create a function, we call it heap5. Heap5 is going to take in Heap5 is going to take in a list. So I'm going to call this my list. Then it's going to take in n, and then that's going to take in I. I'll explain what n and I are. So max. So to get the maximum, we need a maximum. We need a left element. Then also we need a right element. If you're familiar with binary trees, so our max is going to be equal to I. Our left element, if you know this formula, it's what you use to get the left element of a binary tree. It is basically 2i plus 1. Then our right is usually 2 multiplying by I, then plus 2. Those basically are positional like indices in where you can get the left element of the binary tree or the right element of the binary tree. That is the parent from the parent tree. If you've read about binary trees, please do, and if you've not yet read, please go read again. Thank you. So now if the element is greater than the root, we're going to swap. So we say if left, let's start with the left part. If left is equal to n, greater than or equal to n, less than or equal to n, and this my list, now we call our list, and our list at that particular time whereby our left is greater than our max. Let me see here. Yes, our max in that list. So our max in that list, that means we swap. I'm going to explain this a little. So it means our max equals to left, because our left is greater. So we're going to do right. So I've explained this. So if left is less than or equal to n, and then our list, which is left, the left element is, remember this is an index, so our index whereby the left element, the left node, is greater than the max number which we just assigned I from our function. When we declared our function, remember our maximum is equal to I. That's why I put this I here actually. Then our left is equal to this, then our right equals to this. So if our left is less than or equal to n, n is the number of nodes, and then our list is equal to our left element in that list, in other words, is greater than the maximum element which we've assigned to be I, then we shall switch. So we'll do the same thing for right. If right is less than or equal to n and my list, actually I can just copy this. Maximum equals to right. Just put here right. Yeah, that's it. It's the same thing basically. But what if the left and right are not equal to not greater than max? So there's another condition you need to check here. So that means if our maximum, in other words, that we have is not equal to I. This is what it means basically. Not equal to I. That means we shall just basically swap. So you can say our list at that particular I then my list at that particular max, just swapping them here. That means our max, in other words, our max is our list at I is equal to our max. That's what it's trying to mean here. We are trying to compare now I and max. If left and right do not fall to what we are trying to implement, that means our max is going to be equal to our I. So that means our list at I will be equal to our max. So we just say max. Just copy this again. Equal to this. So just swap here to say max I. So that's it basically. Maybe after that we may need to recursively now heapify the affected subtree. So here we can call a heapify function again. Remember it uses recursion. So we put in our list again. This is a subtree now. This continues on the node, then our n, then our max. That's it with the heapify function. So now we can now create a Heapsort algorithm. We can call actually this Heapsort, which is going to take in a list. Also, I'm going to call it also my list. Then from here, let's first get what do we need? We need to heapify the child node, the parent nodes, not the parent nodes actually. You see a binary tree. A binary tree has a root node, then it has also those parent nodes. So root node usually doesn't have another node attached to it. So for us to get the child node of that, like the parent node which is from the root node. Hope my explanation is clear. So we need to get the length first. We can call the length of a list. Maybe we call my list here. Find out the length first. Then now let's use a for loop. I'll explain how I'm using a for loop. For I in range, we're going to iterate through that child node, that subtree. In other words, it's a subtree from the root node. So basically it's going to be usually a flat division by 2 to get the, if you're familiar with binary trees, it's usually a flat division of 2. Then our start, this is our start, then our step, our stop, sorry, and then our step. Our stop is going to be -1, then our step is also going to be -1, the last element. Then from there, now I think we can heapify again. We can call our heapify function. Then from there, then we shall call our list. Then we shall now keep removing from the nodes, and then I. Then we call in. So we shall need another for loop to help us swap the maximum element with the last. Yes, so we shall need another for loop to swap the last element actually. Yes, the last element of the maximum heap with the first. So we can create another for loop. We say for I in range, this one is going to basically now take in the last and the first element. So we shall say n minus 1 is going to be as that element, and then we say our stop is going to be -1 still, also -1. This is our stop, this is our step. Remember, range has start, stop and step, and these are usually optional actually. So from there we can now swap. Yes, we can now swap our I and then with the element at the first element. So the first element is at index 0, then we are swapping it with I. So that means we can say my list. We can say my list at I, and then also my list. Let me just copy this, and then also my list at 0 is equal to just swapping them. So just copy this, then swap. Yeah, that's it. So we again now heapify. Remember, we have to heapify the subtree. So we're calling our heapify again. This time round is going to be my list, that list that we are remaining with. Then I is going to be I actually -1, then at element 0. So from there now we shall test our code to see if everything is fine. That's our Heapsort algorithm. Please, I'm going to link the documentation for you to read more and understand what exactly is happening. So I'm going to create this. I'm going to create a print list, which is going to take a list actually also. Then we're going to loop through the list for I in range my list. Then we shall say print, shall just print I, then we shall end it with the space, change. Then yeah, that's it. Maybe we can add here, we can close maybe the for loop. Let's close the for loop with the print statement. Suppose we started from here. Is it started from there? Okay. This. Indentation is very key in Python. Please make sure you have a better indentation for best results. So here we shall print, let's just print a new line actually. Just put it on a new line. So now let's test the code. So to test the code, we can have my list, which is going to be 23. I had that, that's like 23. 78, let's put in a negative and see if it will sort it. 690, 34, 5. Yes, then our length actually of our list is going to be this, my list. Then we shall print original list. Yes, we shall print original list. Then we also print we shall print the original list, then we print the sorted list. So we can say print, we shall call our print function to print my list, which is not yet sorted. Then we call again now print list, which is going to take my list. That's it. Then we call now Heapsort, which is taking also passing our list, remember. Then we also print sorted list. This is just for debugging. Then we also print my list. And this is after sorting it. So we go run our program, get an error. It's an invalid syntax. Heap find my list, so it's line 19. So come to line 19, we see that it's not supposed to be there. So we run again and we see if we have this object cannot be interpreted as an integer. So list is being called on 30, so it's line 22. So line 22 for I in range my list. For I in range my list, actually, we don't need to put the range. And just for I in my list, we need to put the range. So we run again. -1, 5, 6, and that's it. Our program worked. Thank you so much. Please consider subscribing. Have a great one.